So now you know the trick. How would you isolate for x here? So you have x to the power of 2 over 3 equals to 64. What would you do?
First, we write in the radical form.
Yes, if you want to go the long way, yes.
No.
You guys want to go the long way?
No.
Well, you want to go the short way?
Yes.
Okay, so what do you raise?
I did it the long way.
Okay, so let's see if we get the same answer. If I want to do the short way, what do I raise it to? 3 over 2. Whatever I do to one side, I have to do to the other side. Right? So I have to raise it to 3 over 2. Right? So that and that cancel, the 3 and the 3 cancel, so you'll be left with x equals, and then put that in the calculator. Put 64 to the power of,
Yes.
make sure you put 3 over 2 in bracket here. What did you get?
5.
5.
C.
That's a short way.
So that's it.
That's it.
Then we don't need to think about the other side. Short way is the best.
But you need to know why that works,
But
right?
you explain it in a good way that long
My-
is stuck in my
Mike,
mind.
sorry, can you go through the other route? The other.
No. I gave you too much time on that page.
No. I said.
Which one? I'm recording the lesson. Do you have any specific questions you want to ask, or do you want to copy stuff?
No, I'm not copying. Like if we take this step, the
Yeah.
one we use here, can we learn it too, so that we'll have.
So you want me to do
Yeah.
that in the long way?
Yeah.
Yeah, for sure I can do that. Okay, so to do this the long way, first thing you want to write it in the radical format, right? Remember that with the radical format, this is going to be a cube root of x squared. Okay, so what I've done so far, I haven't solved anything, I just rewrote. Okay, now what do we do to get rid of a cube root? You cube. So to get rid of the cube root, I have to cube both sides, right? Get rid of the cube root, it's done. Okay, so now I have x squared equals to 64 to the power of 3. Okay, now to get rid of the square, what do? Square root. So I'm getting rid of the square, I square root both sides, gone and gone. So I'll be left with x, and then you're gonna have to enter this on the calculator. And you should get 502. So we're doing exactly what we did in the previous question, but the longer, more detailed way. Which way do you like?
I like this method more.
Yeah,
Yeah, I don't know for some reason stacking.
I know. I like this method too. Because this method, I know for sure that I'm doing the opposite operation. I can see the opposite operation. All right. So we're going to look at the word problem. Are you guys done copying this? All right, so let's look at this word problem here. So under annual compounding, an initial investment of $700 grows to $900 in 5 years. Determine the annual interest rate, I, using the compound period, that should be a small I, using the compound formula A equals P1 plus I to the power of N. Okay, so what do we know here? What do we have?
We have our here,
So we have our initial investment, which is what? What's in my initial investment?
700.
And what does it represent in this formula? What's A and what's P? What's I? What's N?
P is the initial investment.
Okay, so P is your principal. It's called principal. That's why they call it P, which is your initial investment. I might have spelled this wrong. Which is your initial. Let's go. Okay, you need to know these letters. Okay, P represents your initial investment, so that's your principal, and in this case, it's $700.
A is 900.
That's right. So A is your amount. A is how much you have in the bank or in the account after a certain time of the investment. A is the amount that you're going to end up with, or if you want, your final amount.
And N is 5 years.
So in this case, your final amount is $900. You need to know this. I is your rate, okay? I is the rate that is percentage. So let's say when you go to the bank and you say you want to borrow money at this percent, that's your I, okay? Now your compounding period is always going to affect your I, but in this case, thankfully, it's an annual, so it's not going to affect it. It's an annual. So if it's, let's say, 5%, it's 5%. Okay? So I is your rate, and N is the period of time that you put it in. Okay? We're not going to have time to do a finance unit in this course, just because of the shortness of time. I wish we had it because this would be the most beneficial unit that you would do. But I and N, when we're talking about compounding period, technically you should be dividing your I by your compounding period, and you should be dividing your multiplying your N by your compounding period. Okay? So what that means, side note, don't write it here, is let's say if I have compounded monthly. Okay? How many months do I have per year? 12. So let's say if I have 5% compounded monthly, I have to find my I is 5%, right? But because it's compounded monthly, I have to divide it by the number of months per year. Okay? You divide. Because what happens is, if the bank is going to give you something, a 5% annually compounded monthly, okay? That 5% has to be divided equally to each month. That's why we have to divide that 5% by 12. Okay? Now, what makes a difference is how many times is the bank going to give you the interest. If they're going to give you the interest monthly, for let's say you put it in the bank for 10 years. Okay? Let's say you put that $500 or $600 or whatever money, you put it in the bank for 10 years. How many times is the bank going to give you interest? If it's monthly.
So 12 times 10.
12 times 10. So that makes your N being 12 times how many years you put it in, right? Because they're going to give it to you every month, right? So whenever I have compounded monthly, I divide my I by 12, and I multiply my N by 12. Okay? Now what if it was, let's say, compounded weekly? That's another lesson, by the way, guys. What if I have compounded weekly? What happens there?
52.
I have to divide my I by 52 because I have 52 weeks. And how about my N?
52 times 10.
It's 10 times 52. So you see that you always multiply your N, your number of years, by your compounding period, and you divide your I by your compounding period. Now, in the case of our example here, it's compounded annually, right? Annually means once a year. I'm not going to divide, I'm not going to multiply because it's 1. That's not going to change anything for me. Okay? So, I'm looking for I, and I know N is how many years? 5. So now I'm gonna have to plug in my information into the formula. Okay, I'm looking for the rate. If I plug in my information into the formula, A is 900, P is 700, 1 plus I to the power of 5. What do I have to do? Isolate for I. So what's the first thing I have to do to isolate for I? Remember, we're isolating. We're using algebraic model.
900 minus.
900 divided by 7.
Divided by 700, right? Because there is a multiplication there, right?
Yeah.
So if I'm going to take that 700 over, it's going to become 900 over 700. Then what do you want to do after that?
No, first it's going to be 900 over 700 equal 1 to power 5 plus I to power 5. No. Yeah.
No.
Didn't you bring the 5?
So how would I bring the 5 to the other side?
Whatever
The
that
fifth root. The fifth root. I'm getting rid of that power of 5, right? So I have to fifth root both sides. So I'm going to fifth root 900. That's a 5 here. Over 700 equals to 1 plus I. Then I can bring the 1 over and I can subtract. Fifth root of 900 over 700 minus 1 equals to I. So what's the fifth root of 900 over 700? Make sure that you put your bracket properly. I'm not going to keep reminding you of this.
Both sides.
Oh, you press the 5 first and then you use the...
Shouldn't be 1 point. Did you subtract 1? There's something not right there. Okay, let's see who gets this answer.
0.05, 1, 5.
Yes.
Which is 5.15%, no? Yeah, which is 5%, 5.15%. We'll talk about the percentage in a second, okay? How do you go from decimal to percent?
This time's 100.
Times 100.
Do we round that or no? We just do that at 1 plus 1.
5.15 is good enough.
Minus 1?